Hello everybody and welcome back to the multiplayer project, where last episode we did add materials to new tiles, but we did not necessarily do second pass support for new tiles. I'm not sure we're going to get this 100% done this episode because I'm not very prepared for this, but we are going to give it a go, and the first thing that I want to do is make sure that to do is pinned. There we go. We are not going to need tile open or tile set for right now, but I do want to create a quick helper method in tile data, and we're going to make this be public bool connected, and we're going to do tile data other. So this will just return true if our tile is connected or not. And for right now, we may expand this later, but for right now, this is just going to be really simple. If we take the absolute value of our other.x minus x, and that is greater than 1, or if the absolute value of other.y minus y is greater than 1, or if other.height is not equal to our height, then we will return false. Otherwise, for now, and this is a naive approach, otherwise we will return true. Now, I'm aware that that's probably going to cause some false positives, but we'll tackle those as we get to them. So let's just hop over into our map here, and the first thing that I want to implement is in our second pass. Let's see, our second pass is down here. We'll get rid of this because that is complete for now. And we are going to do a new region here, and this is going to be corridor caps. And we'll end that region. Wonderful. And I did realize that we're probably going to need diagonal corridors. That is going to be interesting to try to do. But for right now, all we're going to do is, for our corridor caps, if our tile.terrain shape is equivalent to terrain shape.peninsula, so we already know that it's connected on one cardinal direction and everywhere else is lower, right? We already know that because it's a terrain shape.peninsula. So now we can say if any of those that are adjacent to it and the same height is a corridor. We don't want this to become a corridor if the adjacent tile is above or below it. So if tile.north.terrain shape equals terrain shape.corridor and tile.north.height equals tile.height, then we can say tile.terrain shape equals terrain shape.corridor cap. We shouldn't need to rotate this because it should already be rotated, but corridor cap doesn't exist. So let's hop over to our tile data here and do a corridor cap in our terrain shape enum. Wonderful. And now let's get support for getting the tile from that. So we can then do case terrain shape.corridor cap, and we will return, we'll query flooded. If true, we will return tileset.shore corridor cap tiles, which doesn't exist, .get random item of type tile, and we'll pass in our random generator. Otherwise, we will do tileset.cliff corridor cap tiles .get random item of type tile, and then we'll pass in our random generator. Excellent. So that supports that, but we don't have our tileset.shore corridor cap tiles. So just so this compiles, let's do public, if I can type, public list tile, shore corridor cap tiles equals a new list of type tile. We're not going to populate that for right now, but that's just so that this compiles up. Wonderful. Now we've got an issue right now, which is... oh, this needs to be an assignment, not an evaluation. Okay, so we're just going to copy this. We're going to paste it 4 times. We're going to change this to south, and this to south, this to east, and this to east, this to west, and this to west. Perfect. So now that will get turned over, although these don't need to be all ifs. We can make these else ifs. We don't need to evaluate it if any of these are true. Just a very small optimization there, I guess. Okay, so that should be our corridor caps. So I'm going to fire up the server on the other screen here, and once again, no changes have been made to the server. Okay, let's fire up the client and get logged in and see if our corridor caps are working. Hopefully they are, and then we'll figure out which object we want to cover next in our second pass. Assuming that the encryption handshake goes through, which is a bit of an assumption, to be sure. There we go. Wonderful. Also, I don't like how it flashes like that. I'm pretty sure that is because of the generate lighting, but we can actually look into that. Okay. So here we have a world, and we can see that down over here, there's a small issue right here with this tile, because it doesn't really know what to do with this tile, and fair enough, we didn't really tell it what to do with this tile. I'm actually going to pause this so we can move the camera around a little bit more freely. This tile right here, we really didn't tell it what to do in this situation, right? Because this tile to the north and this tile to the southwest are both lower. What should it be in this case? This is a diagonal, so this is also a diagonal. So this over here should be a diagonal, but over here, this should really be an inside corner. Correct? This is a diagonal, this is a straight. Okay, so this tile here should actually be a straight to diagonal, but that's not what we're here looking for just yet. This is what we're looking for. Corridor caps. That's ideal, but yet we still have peninsulas when it's not a corridor. Perfect. So that's working fine. Now I want to try to tackle some of these straights that should be normal to diagonal. I don't know if they're going to be facing the correct direction, but I'm just going to turn off the server here so that it doesn't change our focus in a moment when I save this. And we're going to create ourselves a new region here, and this is going to be normal to diagonal. And we'll end that region. Okay, so let's think about how we need to detect this. If we've got a straight tile that is connected to us, and a diagonal tile that is connected to us. Okay. So, if tile dot, we'll call this, we'll do our situation that we've got right here first. So that's tile dot west dot connected to tile. So if we're connected, and tile dot west dot terrain shape is equal to straight, terrain shape dot straight, then we need to make sure that our tile dot, this would be southeast dot connected, and if I can find the right button, there we go, and tile dot southeast dot terrain shape equals, this would be diagonal. Okay. And this should all be only happening realistically. Actually, I want to have this be slightly different than that in terms of the formatting. There we go. This should only be happening if tile.terrainshape equals terrainshape.straight. Okay. So, what have I messed up here? That's a good question. Have I messed up anything? Okay, what's the compiler got here? Well, this should be, first off, a comparison. There we go. And what's it? Bool and method group. Oh, of course, because we need to do tile. I'm a moron. Okay, there we go. So, if this is the case, We don't really know if this needs to be rotated, but what we do know is tile.terrainShape should be equivalent to terrainShape.diagonal to normal. And it may need to be inverted. We're going to have to test this and see. So that's the case for west and southeast. And then we're going to copy this and paste this 4 more times. And this did not go quite as I was hoping. There we go. That's more like it. We'll go ahead and put in else's here. Because, again, we don't need to evaluate these if we are... if one of these evaluates as true. We don't need to evaluate the rest. So, else if tile dot... Let's do east, so this will be the opposite. So, if our east is connected... And actually, realistically, west could go 2 directions, couldn't it? It could go to southeast, and it could also go to northeast. So that is definitely a wrinkle. Okay, I'm going to get rid of this, and I'm going to recopy this and paste this here. And we're going to go with northeast. And then this will be northeast as well. Okay, so that gets our west side done. So we're going to need 8 total of these. Okay. Realistically, that means that we don't need to evaluate this twice. So if tile.west.connected tile and tile.west.terrainShape equals terrainShape.straight, then we can evaluate these, like so. And then we don't need to re-evaluate this, so we can bring this down to 1 line and make that a little more clean. Good. Okay, that's not so bad, really. So now we'll just do an else here, and then we'll paste this in. And then this will be tile.east and tile.east, and this would be tile.southwest, because these would be both west side. So this would be then tile.northwest. Wonderful. Okay, we'll paste this in again. And this one would then be north, as with this one. North.terrainShape. If tile.southwest.connected, so instead of southwest, it would be, yeah, southwest is fine. This would then be southeast that we'd need to grab. So we would do that like so. And then we'll just copy that in right there, and this would be tile.south and tile.south. Wonderful. And then this would instead be northwest and northeast. Oops, that was not what I wanted to do. I want to do it right here. Okay, so that should get us our normal to diagonals. In theory. Let's test that. I'm going to fire up the server, and we're going to see if that does the trick. With any luck, that will. And also with any luck, the encryption handshake will go nice and quick. And with normal to diagonals, I'm willing to bet some of them are going to need to be inverted in terms of their scale. And so we're probably going to have some issues there. We might have a few rotational issues with this as well. So let's take a look. Okay, so we can see that there's some issues right here. And I think that's because this was only for straight tiles going normal to diagonal. This is an outside corner. This is a diagonal to normal, as is this, which then goes to a diagonal. And this should just be a diagonal in this case. Yeah, and that's something that we can tackle a little bit later. We're looking for a case of a straight line that is going to a diagonal, like this. And I didn't mean to move that. So this is going diagonal to normal. Oh, these aren't tagged. Okay, we can make sure that they're tagged in a moment. So that goes diagonal to normal, and then there's a peninsula, and then there's a diagonal, and then we've got this structure here, where this should really be a diagonal, because it's a cliff corner outside, and then we need to check to see if there's a connected diagonal. That's something that we can definitely do. The straight cliff here is also a bit awkward, but it actually isn't the worst thing. But it looks like we have our straights going to diagonal to normals. Now we need to try to find a location where that is incorrectly rotated or scaled. And I'm just wondering... Oh, this is kind of interesting here, this structure. That's something that'll need to be addressed. But we'll come back to that. Is this a situation? That's a diagonal to normal. Okay, so these are just situations where outside corners need to be made into... Oh, that actually works super well. Look at that. That straight cliff actually works super well going into this corridor. Fascinating. This is then a straight cliff. Ah, this is a diagonal to normal. Now, why did that happen? Huh. That's a straight cliff. Straight, straight. Okay. So it can't be this code, right? Because it has to be adjacent to a diagonal. It is required to be adjacent to a diagonal. No diagonal, no diagonal, no diagonal, and oh, this one is technically a diagonal. Okay, so this is one of those situations that I was talking about where our connected was a bit naive. So in this case, we need to be checking for, let's see here, right here, we need to be checking the rotation. I'm gonna just save this quick, and let's just think about this. So our current rotation here on the y-axis is 0. So on the z-axis is 180. Apparently this is rotating on the z-axis? Okay. Apparently it's rotating on the z-axis. We can maybe address that too. That might have something to do with gimbal locking. Let's see here. Transform.local scale. New vector 3, 270, data.rotation. That's just XY, but maybe we just need to pass in a 0 there. That might do the trick. Regardless, we're going to be comparing our rotation from the tile data rotation integer. So what we need here is we need to say if other dot is, or rather if other dot terrain shape dot is diagonal, then we need to be checking the actual rotation here. And this would actually be the case if it's not diagonal as well, for certain things like corners and, well, for any sort of a cliff shape, realistically, we would need to check here as well. But for right now, we're just going to say this is naive to leave this empty. Okay, so for the diagonals, we are going to say if it's diagonal, then we need to say, we need to know what direction it is. So, we need to figure this out, and what's the best way to do this? I mean, we could just check each of these and say, oh, well, it's that one. Alternately, we could look at the coordinates and know it that way. Because we need to know which direction it is, right? We need to know which direction other is in. So at this point, we know it is a diagonal tile. So if the difference between our x and our y added together is equal to 1, then we know that this is not a connected diagonal. Okay, so if mathf.abs, we take the absolute value of other.x minus x. Actually, let's just, if we're going to calculate this multiple times, let's just declare integers here. Int xdiff equals mathf.abs other.x minus x. Int ydiff equals mathf.abs other.y minus y. Okay, so if we'll change this to ydiff, we'll change this one over here to xdiff. So then if xdiff plus ydiff is greater than 1, then we know that this is a diagonal that could be connected to us, right? Because if x and y are both 1 different, and we're taking absolute values here, so it can't be -1. -1 would be converted to 1. So if we're northeast, xdiff plus ydiff would equal 2. If we're a cardinal direction, xdiff plus ydiff would always equal 1. So if this is equal to 1, we can return false safely. We know this is an adjacent diagonal tile, so it can't be connected. Unless it's a normal to diagonal. Oh boy. Okay, that got a little more complicated than I thought. So we're just going to check this, if this is equal to terrain shape.diagonal. For now, we're going to ignore diagonal to normal. So we're just going to do this. If other.terrainshape is equal to terrainshape.diagonal, we know it's not connected if xdiff plus ydiff equals 1. Otherwise, it could be connected. So we're going to need to figure out which direction it actually is. At this point, we know that it's diagonal. So, if other.x is greater than x and other.y is greater than y, then we know that this is, and actually I'm going to do tile data diagonal. We know then that diagonal is equivalent to, both are greater, so that would be northeast. Okay. Else if, we'll just copy this in, other.x and other.y are both less than, we know that diagonal is equal to southwest. Wonderful. Otherwise, if x is greater and y is lesser, then we know that diagonal equals southeast. Otherwise, we know that if x is less and y is greater, then diagonal is equal to northwest. So we now know what direction our diagonal is in. Wonderful. You know what? Let's make ourselves another method here. I'm going to make this, for now, a private tile data. And this will be get diagonal tile. And we're going to pass in tile data. Actually, what exactly would be the point of doing this? I don't know what I was thinking. I guess I was just thinking splitting this off into a different method for cleanliness' sake, but no, we'll pass on that. For right now, anyway. So, we now know which direction we're in. Kind of. Let's go ahead and... Well, actually... Do we even need to do this? We're northeast. Like, we need to do this check, right? But I'm not sure we need this reference here. This would be... We're southwest. This, of course, would be... We're... What was that? Southeast. Nope. Redo. We're southeast. And this would be... We're northwest. Okay. So, if we go back to Unity here, and we take a look at the tile that we're looking at here, this tile here, we know that we are not connected here because our rotation is 180. If the tile that we're looking at is, in this case, south, this would need to be south and east, then our rotation would need to be this. It would need to be 90. So, for southeast, if other dot rotation equals 90, return true. Otherwise, we will return false. And we'll have this always return false, actually. So we don't even need to do this. So, if other dot rotation is equal to 90, we'll return true. So for southwest, if we're southwest of the tile, so if we're over here, then this would actually be correct right now. So 180 is what we need. So we'll do 180 here. And then for northeast, if we want to connect northeast, actually 180 connects northeast as well. Let's see. Because one side is higher, one side is lower. If we're over here, that could be the case. It depends on what way this tile is flowing, right? Yikes. Okay. We know it can't be connected if it equals 270 or if it's equal to 0, right? Other dot rotation equals 270 and then 90. We know for a fact that that can't equal southeast, correct? So we're southeast here. This is 180. Actually, 270 and 90 are the ones that can be it. 180 and 0 are the ones that can't be it. 0 and 180 would return false. If we get all the way down here, we'll simply return true. Okay. So we're southwest at this point. We're going to copy this. What are the directions that we cannot be if we're southwest? If we're southwest, the directions that we cannot be would be the same thing. 0 and 180, correct? Well, no. 180 actually connects. 90 and 270 are the ones that don't. So we need to then make this be 90 and 270. Because if we're back over here in Unity, and we bump this guy over here, I mean, we can't really see it. If we're connecting to, at this point, the southwest tile, remember, we're doing this from that tile's point of view. So we're in this tile, and we're comparing to this tile. It can connect if it's 180, but it also could be connected if it is 0. It cannot be connected if it is 90, and it also cannot be connected if it is at 270. Neither of those could be a possibility. So in that case, we'll return false. So for northeast and for northwest, we'll do the same thing. Let's see here. Southeast is currently set to 0 and 180. Yeah, those are the ones that cannot connect. And then for southwest, 180 and 0 can connect. So it's 90 and 270. So for northeast, we are in this tile. 180 and 0 can connect to northeast. So if it's 90 or 270, then it would return false. For northwest, that would mean, of course, that 0 and 180 are unable to connect to northwest. In this particular case, that would mean that we're connected here, or rather, that we're connected here. So 180 obviously doesn't connect this way, neither does 0, so those are the two that cannot connect. Okay, that's if we're diagonal. That doesn't take into account diagonal to normal. But let's go ahead and fire up our game here and see what exactly that did. There's so many variables to this, it's insane. Come on, you can connect. In the meantime, I guess I can just double check this here. Yeah, that all seems fine. So that doesn't take into account diagonal to normal. So we expect that there are still going to be issues there. If we come up over this direction, we can see a few different things. One, we can see that there's a bit of an error over here because we have these straight tiles that are connecting into the full peninsulas. If that's the case, the straight tile should be normal to diagonal. We'll tackle that in a moment, though. Now, I want to... That's always interesting, seeing it create the same exact shape multiple times in a row like that. I want to check for one of these situations like we just had. Let's see here. These are diagonal to normals. And then that's that cliff corner outside that really should be a diagonal. And we'll do a check for that probably next episode. This is getting such a bog down, but this is also a huge portion of this game, right? Like, this is every overworld map that's going to be generated with this system. Not dungeon maps. Dungeon maps are going to be generated differently, but this is the overworld maps, and that's going to be very, very important. So that's why we're spending so much time on this. I think, let's go ahead and fix this. I'm going to turn off the server quick. And we're going to pop down in our map over here. So these are corridor caps. So if we are an outside corner, let's go ahead and do a new region. And this is outside corners that should be diagonal. We'll end that region. And apparently select everything instead of save, or while saving, actually. Let me scroll back up there. Okay, that is not our healing area. Can I just do this? No, I cannot. Wonderful. Okay. This is our generate terrain data. I'm just going to close these then. Ah, this is where we need to be. Okay, so outside corners that need to be diagonal. So if tile.terrainShape equals terrainShape.outside corner, or corner outside actually, now we need to check if there are adjacent diagonal tiles, like this one. Wait, I was doing outside corners. Right, because I was doing ones like this, where we have a diagonal corner here, or just a diagonal here, and then this is a diagonal to normal. Well, that's going to break this structure, actually. Yeah, we can't do it that way, the way I was just thinking about doing. So I guess we'll tackle this instead. So if we have, instead of outside corners that should be diagonal, this is going to be smoothing straight to peninsula. So if our terrain shape is equal to terrain shape.straight, then we are going to go ahead and say something along the lines of, if we have an adjacent peninsula, so if tile.west.terrainshape equals terrainshape.peninsula, then we are going to, at this point, let's see, we're a straight tile, so we already know that the one next to us should, in theory, connect in at that central point. So we need to make this be, at that point, pretty much no matter what, a normal to diagonal. So tile.terrainshape equals terrainshape.diagonal to normal. Now again, we may actually need to we may actually need to do some rotation or scale correction here, but we'll find out. Else if tile.east.terrainshape equals terrainshape.peninsula, then our tile.terrainshape equals terrainshape.diagonal to normal. Excellent. And we've already dealt with corridor caps at this point, in theory, but that's not actually done. This might cause some false positives with corridors, in theory. Okay. We'll continue this and see what it ends up doing. And we may be able to fix that a little bit later on. Actually, well, yeah, it's almost certainly going to cause some issues. But we'll just do south and north. And we're going to fire this up and see what it actually ends up doing. Like, it's going to cause issues. But I don't know if we're going to immediately see it in this map or not. But there's 100% going to, at some point, be false positives from that one, because it's checking a peninsula that should be a corridor cap. You know how we fix that? By checking to see if it's connected. That's how we fix that. Okay, so we are now seeing things like this, which is fine. We're seeing things like this, which with an outside corner. What we're really looking for is connections like, well, that's a cliff corner outside. Like this, that's a diagonal, and that's a diagonal. Okay, that's not relevant. That's not what we're looking for. That's a peninsula. That's actually a double peninsula there. This is actually another one. Okay. Ah, this looks like what we're... No, that's a corner outside. That's a straight corner outside into diagonal to normal. And then this situation here, which really should be... This is a diagonal to diagonal, and that's a new tile type that we're going to need, as I've pointed out in the past. Let's see here. Here's a situation. Okay, so that's a normal to diagonal. That was already a normal to diagonal. Yeah, I think this is just a scaling issue. So if we do this like that, yeah. So that's a scaling issue, I'm pretty sure, because that needs to be a diagonal to normal. That's a straight cliff, that's a corner outside. We're specifically looking for these peninsulas, like this one. Yeah, and then this is a diagonal to normal here. And this, again, needs to be inverted. And now that would fit. Okay, so let's logic out this situation and figure out when these need to be inverted. So in this case, the peninsula is to the north. And the lower position is to the east. So if the tile is to the north, then we need to say, actually this is fine having this be tile.terrain shape. Let me kill the server quick. But let's then just say if tile.east.height is less than tile.height. We also need to make sure that these are connected. So, and tile.west.connected tile. So let's make sure these are connected, like so. Just going to paste this in here and then change this to east, and then south, and finally north. Okay, so if tile.east is less than tile.height, else if tile.west.height is less than tile.height, then we need to say tile.mirrored equals true in this case, and tile.mirrored equals false in this case. Now, of course, this connected is not fully fleshed out, right? We need to know multiple more things to know if it's connected or not. But that'll do for now. But that's only going to fix it in the one direction. So if our east is our lower, then that means that we're facing that direction, and yep, that's 100% correct. So the same thing is true for south, except I believe it needs to be inverted. So if we're looking at it from this direction, and it would be like this, then yeah, it needs to be tile mirrored equals false, I believe. Or not, no, this is north. This one would be false, and this one would be true. Okay. And then we'll also do it for east and west. So we'll just, nope, we'll do that. There we go. East and west. Okay, so this should, of course, be north, and this should be south. And I'm not going to test these and figure out which these are. If we note that they're wrong, we'll switch them around. This will be north, and this will be south. And I'm just going to say true and false for right now. Like I said, if we note that they're wrong, we'll switch them around later. Okay, so let's fire up the server and the client one last time here. And this should give us, well, something. I don't know what it'll give us. It'll give us something, though. Okay, let's see what it gives us. Well, there's this issue right off the bat, obviously. That issue is fully expected, and let me just get over to the corner over here. Yeah, we haven't implemented this yet, where it's an outside-inside corner. This is, of course, diagonal to diagonal. This is an outside corner that should be a diagonal. That's something we have noted in the past, but don't currently support. This is an outside corner, as is this. Just looking for peninsulas. These are all outside corners over here, I'm quite certain. Here's a peninsula, I think. Yeah, that's a peninsula there. And we can see over here that the diagonal to normal is correctly mirrored. Fantastic. Sheer luck. This is an outside corner where it should be a diagonal. Again, that is a situation that we can handle a little later on. We need to note that diagonals also include peninsulas. Peninsulas only connect diagonal. Currently. We'll probably need to have a variant that comes out like this and then connects diagonal, but for now we don't have that. There's just so many variables to this, but we're getting there. It's definitely improving bit by bit, episode by episode, but it is a lengthy process. Anyway, I'm going to go ahead and stop here, and we got some additional second pass done. But we're by no means complete. So I'm going to put a cut in here, and next episode we're going to continue our second pass, as well as most likely working on our connected method here. We'll see about that. You can leave your offerings to the engagement gods in the form of likes, comments, subscribes, and bell ringings, and I will see you all next time. Also, I just noticed the music was turned way down. I apologize for that. I'll see you all next time.